All right. So, the next topic that we are doing is redox, and redox is a specific type of reaction, and in fact, most reactions that we are dealing with are redox reactions. What I've provided you guys here as our writing kind of template is the same template you guys are going to be using on the exam. So I want to get you guys used to it. The other thing is that I will color code the answer for achieve, merit, and excellence so you know how to kind of upgrade your answers. Today, we're just going to be focusing on the achieved, so I'll be writing that in red. So when you guys look at any scanned examples, you'll know anything in red, that's the achieved requirement. First thing I need for the achieved is your observation. So we need to state what do we see happening in that reaction. So the first thing we could state is we looked at magnesium. And magnesium was a gray, shiny metal. And it was a solid. The other thing that I'm going to write down in my observations is the sulfuric acid. So that was H2SO4. And I noticed that when I was looking at it, that was colorless. And it was a solution. So aqueous is what that was. Are you okay with that so far? All right. And I can double check that I have the right observations and the right items, because if I look at this resource sheet, I can see that magnesium, Mg here, is a metallic luster. And I can break this apart into the hydrogen ion and the sulfate ion. And I can look at both of those guys. Sulfate's over here. It is a colorless ion. And the hydrogen ion right here is also a colorless ion. So it verifies what I've been looking at. Are we good so far? Right, then we need to think about what happens with that reaction. So after I mix those two things together, what did we see happening? We saw bubbles. And what was the solution color? Colorless. So, and solution remained colorless. Oh, colorless. There we go. All right, now we got to figure out what is causing those observations that we are seeing. The first main one is the bubbles. So I want to think about what could these things become. So when I'm looking at this here, I see that there's magnesium. And the other thing that I have that has magnesium is the magnesium ion. Actually, we should write that down. Bubbles, solution remained colorless, and the metal disappeared. I write the word disappeared because it's not actually gone, it's just changed. So when I look at this, I see that magnesium probably has become the magnesium 2 ion, because that is a colorless ion that is soluble in the solution. So part of this colorless solution is the magnesium 2+ ion. Do you guys agree with me on that? Does that make sense? Okay. The next thing I need to think about then is what is happening to the sulfuric acid. Now, only one of these two items are going to be involved in the reaction. The other one is just an observer. So if you guys remember with ion identification, we talked about that a lot with the precipitates. There are a lot of observing ions that weren't part of the precipitation reactions. They just stayed aqueous in solution. So let's look at our options. If I look at the sulfate, there's quite a few things it could have become. It could have become that, it could become that, or it could have become that, sulfur dioxide, which is a gas. So like, ooh, maybe the gas in the bubbles that I'm seeing is the sulfur dioxide. But let's not limit us to that sort of thought process. Let's look at the hydrogen. We have the hydrogen ion, and we also have the option for hydrogen gas. So the bubbles could also be hydrogen gas. Which of the two do you think those bubbles are? What if I tell you that hydrogen's flammable? And what? So the pop test confirms hydrogen gas. So what that tells me is that these bubbles here is H2. I'm just going to write H2, the gas. And we should also write that as a colorless bubble as well. So what that tells me then is the sulfate is just an observer. Are we okay with how I got to that point? Only two things need to be involved in my reactions, and I've identified the two things. So that one doesn't matter. Cool. So first thing we need to do is our observations. Done? Leave it on the desk. Here. You can take a seat here. You left it in the other room? The test? Yeah, it's fine. That's what I want. Cool. There we go. All right. Next thing I want us to do is talk about the redox process. So redox as a reaction is talking about the exchange of electrons. This exchange of electrons allows for chemical reactions to occur. We are going to skip this bit here to start with because I just want to give you guys definitions. So we need to think about oxidation and reduction. So when we talk redox, it's just our abbreviation for reduction, oxidation. So ox. That's where that word's coming from. So this is a redox reaction. In all redox reactions, we're going to have one side of the reaction that's going to donate electrons and one side that's always going to accept electrons. The way I like to remember which one is which is an acronym that goes Leo the lion says grr. So we go Leo says grr. The other one that people like to use is oil rig. So what that means is loss of electrons is oxidation. Gain of electrons is reduction. Or you can go oxidation. Can't remember what the I was standing. Oil rig. What was that standing for? I don't remember what oil rig stands for. I like to use Leo the lion says grr. All right. So let's write down that definition then. So if I'm talking about an oxidation reaction, I'm saying that electrons have been lost. Since the electrons are leaving this half of the reaction, the other half of the reaction is gaining the electrons. So we should always have one half losing, one half gaining, because we can't create or destroy matter. So on this side, I would go, electrons are gained. Are we good so far? Okay. So last thing I need to do is figure out which half of which reaction is forming the oxidation reaction and which half is being the reduction reaction. Now we're starting to go a little bit into the merit territory. I don't want to go into too much depth with the merit territory because I'll do that next week, but I just want to help you guys quickly identify which one's which. So when I thought about the equation for the magnesium, and I like to put my equations in the center, we had magnesium going to the magnesium 2 ion. Agreed? In my other reaction, I had the hydrogen ion becoming the hydrogen gas. So these are just the basic kind of transformations. So I'm going to put these guys down here eventually, but I need to figure out which one is oxidation and which one is reduction. So when I look at this guy here, think about last year when we talked about ion formations. Magnesium has 2 valence electrons in its outer shell. So is it going to gain or lose? Lose to go down a shell. And that's what we see with the +2. So since this guy has lost electrons, this one is my oxidation reaction. So I go Mg, Mg, 2+. And then this means this is my reduction reaction. We good? Questions so far? Caleb's giving me a face like he doesn't quite understand what I'm talking about. All right. Last bit of information, and then I'll let you guys do another practice one, okay? Last bit is talking about oxidant and reductant. Now, this is where things get a little bit tricky because the vocab doesn't make as much sense as it should. We've identified this as an oxidation reaction. My reactant is what I'm going to be putting over here. So we're talking about magnesium. And we need to identify if magnesium is the reductant or the oxidant. We call the reactant in the oxidation reaction the reductant. And the reason why is because we need to talk about what magnesium is doing to the other reaction. So magnesium is providing the electron for the reduction to occur. It is going to reduce the hydrogen ion. Thus, we call it the reductant. It's a little bit counterintuitive. That's how they decided to do the vocab. Over here on this side, I would copy the hydrogen ion down. The hydrogen ion is involved in the reduction reaction. This guy is going to be the electron acceptor. So it is going to be able to oxidize the magnesium. So we call this one the oxidant. If you guys can fill out everything that's in red, you have achieved. You've passed. All you need to do. I will teach you guys how to do the merit and excellence over the next couple weeks, but that's all for the achieved, which isn't too bad. Okay? You guys ready to do another reaction? Are you guys saying it's easy? I'm glad. I'm so glad that you say it's easy. Okay. So, second reaction that you guys are going to do, not as much fun because you're not blowing things up. But this one will have a pretty color change. Okay. I'm going to give you two solutions. One is going to be potassium permanganate. One is going to be iron 2 sulfate. The iron 2 sulfate I will make fresh in a beaker and have little droppers. This one will be in a bottle. You will only need one test tube. Make observations about each one, and then mix them together and see what happens to the color change. Okay? And then try to do that working observations, figure out which one is oxidation reduction, write your justification, which is just defining oxidation reduction. All right, I'll get your stuff out, put on some goggles.